Hello everyone, I'm Paul and this is problem 3689, maximum total subarray value 1. This is a medium problem that might seem tricky if you don't know the trick, so let's see how to solve it efficiently. We are given an integer array nums and an integer k, so let's say that we're given this input, and we have to choose exactly k non-empty subarrays. In case you know what a subarray is, it's a contiguous selection of elements. For example, here, this is a valid subarray. This is valid and this is also valid. But we can't take a subarray with numbers 1 and 2 because these elements are not contiguous. Subarrays may overlap and we can use them more than once. This is very important. The value of each subarray is defined as the maximum number in it minus the minimum number. For example, if we take this subarray, the value is the maximum number, meaning 3, minus the minimum number 1, so this is 2. The total value is the sum of values of these k chosen subarrays. We have to return the maximum possible total value that we can achieve. So if we're given this input, we can take one subarray with 1 and 3, here the value is 2, and we can take another subarray with 1, 3, 2. Here the value is the maximum number, 3 minus the minimum number, 1, meaning 2. So we do 2 plus 2 and this is equal to 4. Given that this is the maximum possible total value that we can achieve, this is the result. Maybe you're thinking about iterating all the subarrays, but here we have the constraints and we know that this array can have a length of up to 5 times 10 to the power of 4. And this requires big O of n squared time complexity. We can do this with a nested for loop. And this number to the power of 2 is a very large number, so we have to think about something else. The key observation to solve the problem is here. The same subarray can be chosen more than once. This means that we can pick only one subarray, only the best subarray. We can pick the same subarray k times, in this case 2. So we can pick either one subarray starting with the minimum possible number and ending with the maximum possible number, or a subarray starting with the maximum possible number ending with the minimum possible number. For example, here we can pick 2 times this subarray, and that's how we get a result of 4. This would correspond to this scenario. We pick the minimum number in the entire array, which is 1. We start with this number and we end with the maximum number in the entire array, 3. So we are here. What if we're given this array? Here the maximum number is 3, the minimum number is 1. So we can pick this array. We are looking at this scenario. We start with the maximum possible number and we end with the minimum number. So if we find any of these two subarrays, it's fine, we can repeat it k times, in this case 2, and that's how we get the maximum possible total value that we can achieve. So the key observation here is that we actually only care about 2 things, the maximum possible value in this entire array and the minimum possible value. So the result of the problem is just the maximum number in the array minus the minimum number times k, in this case 2. Time complexity for this is big O of n because in order to get maximum and minimum numbers we have to iterate the array, and space complexity is big O of 1. So with this in mind, let's go with the code. First we can see that maximum and minimum are equal to minus infinity and positive infinity. Now we can say for every number in nums, maximum is the maximum between what we already have and the current number, minimum is the minimum between what we have and the current number, and after this for loop, now here we can return mx minus mn times k. This is the entire code, so let's see if it works. As you can see, this works and it's very efficient, so if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.